In this video, the learner is going to be able to write a biconditional statement and analyze whether or not it will be a true biconditional. First, we're going to refresh our memories about some of the symbols that we've been using. We have all of our letters that mean just statements. We have implies, negation, and, or, therefore, and then this last one, if and only if. This is actually going to be our symbol for biconditionals. So let's determine what a biconditional is. We're going to first consider the statements P, which is two lines are perpendicular, and Q, that the lines form right angles. We're going to put this in conditional form. P is going to be the hypothesis, Q is going to be the conclusion. If two lines are perpendicular, then they form right angles. That is the statement P implies Q. We're going to use this statement to see if we can write a biconditional statement. So we need to consider the converse of that statement we just looked at. So we had P implies Q. That says if two lines are perpendicular, then they form right angles. Our hypothesis and conclusion are P and Q. Let's go ahead and form the converse, which is if Q, then P, or Q implies P. If two lines form right angles, then the lines are perpendicular. If you look back, you could notice that both the original conditional statement and the converse are true statements. P implies Q. If two lines are perpendicular, then they do form right angles. And if two lines form right angles, they must be perpendicular. Both of those are true statements. This leads us in to talk about the new statement that we can form. When a conditional statement and its converse are both true, we can combine the two statements and form a new statement, which is called a true biconditional. A biconditional statement is formed with a hypothesis and conclusion from the conditional and its converse, with if and only if between them. This IFF here is a shortened form of the phrase if and only if. So you might see me write the if, and that means that we're using the biconditional notation. A way to write that using our symbols is to use that double-sided arrow to mean P if and only if Q. So it means P implies Q and Q implies P, just as if we were writing that conditional and converse in one statement. Let's do that for our previous example. We had two lines are perpendicular was our hypothesis. They form right angles was our conclusion. Now that we know both our conditional and converse were true, we can put them together in this if and only if form. So two lines are perpendicular if and only if they form right angles. Notice we have two lines are perpendicular is our hypothesis. They form right angles is our conclusion. Notice it is no longer an if-then format. It is in that biconditional format. Now, the converse of a statement will not always be true. Let's consider the example, if a polygon is a square, then it is a rectangle. We do know that that is true. This square here is a rectangle. Let's now consider the converse of that statement. We would switch the hypothesis and conclusion to say, if a polygon is a rectangle, then it is a square. Well, not every rectangle is a square, so this would be a counterexample to show that this is false. So here's an important note. Any set of statements can be written in a certain form. So we could put any two statements together to make a biconditional. However, it's only a true biconditional when both the conditional and its converse are true. That's the only way that you can make a true biconditional. It's the only way the biconditional is valid. So in the next examples, we're going to determine if a biconditional can be written. If so, we're going to form the biconditional. So we have the statement, if a polygon has three sides, then it is a triangle. we have to consider both the conditional statement and its converse. Since both of these statements are true, a biconditional can be formed. We know a polygon with 3 sides is a triangle. So if that polygon's a triangle, it's going to have 3 sides. So to form that biconditional, we would have a polygon has 3 sides if and only if it is a triangle. Next we have if your score was a 70% or higher on the exam, then you passed the exam. This is our original conditional statement. Our converse is if you passed the exam, then your score was a 70% or higher. Both will be true, so a biconditional can be formed. You passed the exam if and only if your score was a 70% or higher. Notice that you can put the statements in either order. It doesn't matter whether you start with the original hypothesis and conclusion or you use the order from the converse. Because the biconditional can go either direction, it does not matter. Determine if this biconditional is a true biconditional. Remember, a biconditional is only valid if both the conditional and its converse are true. So the conditional statement and its converse, if 2 lines are perpendicular, then they are not parallel. The converse is if 2 lines are not parallel, then they are perpendicular. Well, if 2 lines are perpendicular, they form right angles and they have to intersect. Therefore, they can't be parallel. So this statement is true. If we take a look at the converse, if 2 lines are not parallel, then they are perpendicular. This is not necessarily true because you could just have a pair of intersecting lines that don't form right angles. That makes the converse false. Because one of those statements is false and one of the statements is true, the biconditional is not a true biconditional, even though it's in the form of a biconditional. Here are some on your owns that I want you guys to try. Determine if these 2 biconditionals are a true biconditional.